This lecture is going to kind of jump back into cardiorespiratory endurance. We're going to talk about assessment and programming as it relates to cardiorespiratory endurance exercise. So, things like walking, jogging, biking, most sports. One of the first things we need to talk about is assessment. And assessment as it relates to cardiorespiratory endurance is really looking at how well your lungs can get oxygen in and how well your body can move that oxygen through your blood and get it to where it's needed in the muscles, and then how well your muscles can utilize those nutrients. And so there's lots of ways that we can assess, and assessment is really important before you ever begin any kind of training. And with cardiorespiratory endurance training, it's also important to know where we stand and how where we need to start and what are some reasonable goals for us. And so when it comes to assessment of cardiorespiratory endurance exercise, the very best way to measure that is through what's called a VO2 max test, or a volume of oxygen consumed test, maximum test. And so this test, what the idea of it is we're trying to measure how much oxygen can your body utilize at the muscular level, because the more oxygen you can utilize at the muscular level, the better you are at delivering that and using that and making energy for competing, let's say, in running or a biking event. So this is the very best measurement, is what we call a VO2 max test, and most people haven't done them for various reasons. So I'll describe the test, and then we'll talk about why not everyone will do this test in their lives, and most people actually won't. So a VO2 max test is not that difficult in itself. I mean, you have to push yourself really hard, but the test itself isn't something strange. The way that it works is typically you come in and there's a device that you're hooked up to that kind of either goes in your mouth or kind of covers your mouth, kind of think like scuba mask type thing. And it's simply something that's going to measure how much air you breathe in and out. And so this device will be hooked up to a computer. It will make sure that it captures all the air that you breathe in and out. You'll breathe in room air, and then when you breathe out, instead of it going back into the room, it's going to go into this box that's attached to a computer, and it's going to measure how big of a breath you're taking, literally how much air you move with every breath, and how much oxygen you actually take out of the air that you breathed in. And so this computer does all this work for us. And so you'll get hooked up to this. And then after you get comfortable, after about 2 or 3 minutes hooked up to this device, it feels weird at first. You'll be accustomed to it. They're going to have you exercise while you're hooked up to this device. It could be any type of exercise that is done. A lot of times you see it on a treadmill. And simply what they're going to do is, if we talk about it on a treadmill, VO2 on a treadmill, you get on a treadmill and you pick a speed that is comfortable, something you could jog at for, let's say, about 30 minutes is a good way to do it. So what's something you could jog at for about 30 minutes? And once you find that speed, if I was your kind of walking you through this test, and there'd be a couple of people there walking you through the test, we'd say, okay, let's start, and we'd start a timer. And every 2 minutes of that test, we would increase the grade, or the incline on the treadmill that you're running on. So you're going to keep running the same speed, but every 2 minutes, it's going to get a steeper and steeper hill that you go up. And so every 2 minutes, it gets harder and harder for your body to keep up and to keep running on that treadmill. And if we do this test correctly, this VO2 max test correctly, you'll be done with that test in about 8 to 12 minutes, if done correctly, somewhere in there. And as that test gets harder, it gets more difficult and more difficult. The incline goes up and up and up. And then your only instructions once you start on the treadmill is to keep running on that treadmill till you feel like you're going to fall off the back, or until you feel like if you take another step, you're going to die. When you feel like you can't take another step, or you're going to die, or you're going to fall off the back of the treadmill, you simply just step off the treadmill. You step to the side of the treadmill, and we'll slow it back down for you to start your cool down. And while this is going on, we're watching you to make sure you're safe and make sure you're not going to fall off the treadmill, and ready to stop that if need be. And so what happens is this computer's measuring how much oxygen you're utilizing. And so we're looking at you, and right before you stop that test, right before you kind of say, that's it, or as you're getting off that treadmill saying, I can't take another step or I'm going to die, we would look at the computer and kind of look at how much oxygen you took in at that particular moment in time, because that's the hardest you can possibly exercise. If you feel like if you take another step, you're going to die, well, that you can't exercise any harder than that. And so we'd look and see how much oxygen you were able to utilize. And so based on that, we would have your actual VO2 max. What's the max amount of oxygen your body can make energy with? And so the higher that number is, typically the better you are at exercise. So the faster you could run. And so this is a good measurement because the only place we use oxygen is to make ATP. And so if we can see how much oxygen you utilize, we can look at how much ATP you make. And so this is really good for us. The problem is this test isn't for everyone. First of all, you have to push yourself really hard. If you don't push yourself really hard on this test, you don't push yourself as hard as possible, it doesn't give us good results. If you can't push yourself hard, so maybe you're not used to exercise, it doesn't give us good results either. And then also, this test takes people that are trained to be able to do so. It does take 2 or 3 people to run this test on one person, and the equipment is quite expensive. That machine to measure your breathing is like $30,000 to $40,000, and it usually is housed in a lab. And the treadmills you use are kind of more expensive and better than like your typical treadmill you see in like your LA Fitness or something. They're really good because of what they're designed to do. But this makes them really expensive, and most people don't actually need that kind of information. Only athletes and researchers really need to know their true VO2 max. The rest of us don't need to push ourselves that hard and put ourselves at risk running on a treadmill for that long, or we don't have the money for it. And so are there ways that we can actually get something similar to our VO2 without having to do that true test? And the answer to that is yes. We have what we call field tests. We have other tests that you don't have to push yourself maybe as hard, or they're not as expensive, but they're good enough for most people. They're not quite as accurate. They're not quite as good, but they give you a number that you can start to use to assess yourself with to train and see if you are progressing. And some of these tests you've done before. So we've got things like a 1 mile walk test where you simply walk 1 mile as quickly as possible. And if we know how long that took you and how high your heart rate got, we can estimate the same number we got through the VO2 max test. Not quite as accurate, but good enough. We have a 3-minute step test, which is basically stepping up into a chair and stepping down for 3 straight minutes. You see how many times you can do that. And so the more times you can stand up in a chair and step back down onto the floor in 3 minutes, the higher your VO2 is typically. We also have the 1.5 mile walk/run. So you cover 1.5 miles as quickly as you possibly can. So you walk it, you run it, you do a combination of the two. But you cover 1.5 miles as quickly as possible, and based on how long that takes you, we can estimate your VO2 just like from the actual exam, and it's not as dangerous, it's not as expensive. We can test a lot more people at one time. There's also the beep test, or it's actually really referred to as the pacer. Should be referred to as the pacer. That's how it's known. Maybe you did this in high school. This is where you got at the gym and there was a tone, and you had to run to the other side before the tone hit again, and then you turned around, and as you went, those tones got closer and closer together, so you had to run faster and faster across the gym. Based on how many times you went back and forth, we can estimate your VO2. Realized field tests can be a variety of different things. It doesn't have to be walking. There could be biking tests, rowing tests. There's even a 12-minute swim. So how far can you swim in 12 minutes? And based on that distance, we can estimate your VO2. Again, not the most accurate, but they definitely give us they give us a picture of where we stand, and we can utilize those. With that, we can also kind of assess we can assess ourselves using heart rate. So using a heart rate monitor or palpating at our carotid artery, which is in our neck, or our radial artery in our wrist. Realize if you're doing exercise, we don't want you to palpate your heart rate in your neck, because you could block blood flow to your brain and cause yourself to pass out. We actually prefer the radial site for looking at your heart rate. And realize heart rate is measured in BPM, or beats per minute. How many times did your heart beat every single minute? And the way we'd use that for assessment is if we said that you were going to walk a mile in 20 minutes. So that's what you're going to do. We're going to walk 1 mile, and it's going to take you exactly 20 minutes. No faster, no slower. Well, if you did that the first time and you were untrained, your heart rate might hit 150. Well, after we train for let's say 6 months, and we do that again, and we say we're going to walk a mile, and it's going to take us exactly 20 minutes. As my body gets better at exercise, what we're going to see is that heart rate is not going to have to get as high to get us to that point. And so when we walk that mile in 20 minutes, what we may experience is the fact our heart rate only gets up to 120, and that would show us that we are progressing. The biggest thing when it comes to these results, no matter which test you decide to use, is the fact that you need to use what we call a normative table to look at your results, and that's because you may at some point start to learn what a good test result is, but you may not. Kind of think like when you took the SAT or the ACT, you were given a number. You were given a number at the SAT. Maybe it was a number of you could get a score on the SAT, I think, of like 400 or 500. Well, 400 or 500 sounds really good on your traditional test where you get 0 to 100. You're like, man, 500, that's, 400, that's fantastic. But when you start to look at it, you realize that 400 is actually not that great of a score with an SAT score. And so a normative table simply lets you know where you stand. It compares you to other people. So when you get your results for a VO2 max, it's going to show you with people your age and your sex. So if you're male, that is the age of 20, well, how does your score compare to everyone else? Is it average? Is it above average? Is it below average? And so it allows you to know what that score actually means. I could throw out a number of saying I had a VO2 of 100, and you guys wouldn't know what that means at the moment. 100 would be impossible. No one's ever gotten a score or a VO2 of 100. Literally the highest score of the highest number of a VO2 we've really ever seen is in the 80s. If someone said they had a VO2 of a 5, well, that would be very concerning because that's a very low number. But an average college student has a VO2 somewhere in the 30s to 40s, lower 30s maybe to lower 40s. Some maybe even be in the 20s, and that's perfectly okay, but you wouldn't know that until you looked at these normative tables. And then finally, we want to make sure that you also, when you reassess yourself, use the same test. Use the same test that you did the first time, because if you ran the first test and you swam the second test, your results really aren't comparable because maybe you did better because you're a good swimmer and not a good runner. And so those don't really paint a true picture of what we're trying to get with these. Once you have your assessment results, what we want to do with those is we want to use those in order to develop a program for you to be able to exercise with, to do cardiorespiratory endurance with. And so the first thing before you develop a program, you have to set a goal. You've got to set SMART goals. You can use your assessment results or heart rate. A lot of people with cardiorespiratory endurance exercises use time or distance goals. So maybe I want to be able to run a mile without stopping, or I want to be able to run 13 miles, or maybe I want to be able to run 3 miles in less than 30 minutes. Things like that. Your first goal should always be to reach 150 minutes of activity a week, which we talked about in previous chapters of why that's important. Once you do that, though, to be able to set your goal, to reach those goals, to start reaching for them, you're going to use that FIT principle. And so when it comes to cardiorespiratory endurance exercise, frequency, the F in FIT principle stands for frequency. We say 3 to 5 days per week, and we really want to strive for that 5 days a week. We don't say 7 because we want to make sure you get rest. If you're a beginner, we'd say 3, or if you're really having trouble with the schedule, 3 days is fine. We really want to try for that 5. We want to make sure that we spread those throughout. So if you're only going to do 3 days per week, make sure you're not doing Monday, Tuesday, Wednesday, and then taking 4 days off. This isn't going to be good. We want to make sure that we would do something like Monday, Wednesday, Friday, or Tuesday, Thursday, Saturday. The I in FIT stands for intensity. So intensity is how hard are we having to work? How hard is that? It's important for us to change up our intensity. We can use all different kinds of things for intensity. It could be your heart rate itself, so a target heart rate zone of saying, I'm going to make this exercise, I'm going to run at a pace that makes my heart rate stay around 150 beats per minute, or maybe it's up between 150 and 160. We can use something called METs, or metabolic equivalents. You can find charts on this, but it's just how much energy is going into that exercise. You sitting right now watching this, you're at 1 MET resting. If you start walking around wherever you're at, that would be maybe like 1.2 MET, so it takes a little bit more energy, but not a whole lot more. If you start running as fast as you can, that could be 8 or 9 METs, and so you can kind of gauge it from that. You can use RPE, which is a scale from 6 to 20. RPE stands for rate of perceived exertion, and it's on a scale from 6 to 20. 6 is resting, doing nothing. 20 is the hardest exercise you've ever done in your life. And so if you're running, this is a cheap way, or exercising, this is a cheap, easy way, where you're just saying, well, how hard does this exercise feel? And once you get accustomed to the scale, it can be very, very useful. If you're on a light walk, maybe you're like, it's not too hard, so maybe it feels like an 8 or a 9, and that's light exercise. Start jogging, and you think about how your whole body feels. Well, maybe that's a 12, and it's kind of moderate. And if you start running uh, at a faster pace, maybe that feels like a 15, which is really hard exercise. And so it's a way for us to gauge that. You can even use, with the intensity, you can use something I like to call as the talk test or the breathing test. And it's basically how easy is it to have a conversation as you exercise. Um, if exercise is really easy to you, it's really easy to have a conversation as you're doing it. As that exercise gets more intense, as it becomes moderate intensity, that exercise it starts to get harder to talk while you're doing it. And so maybe it's a little spaced out. Maybe it becomes a little bit more breathy. And then as exercise gets even harder, maybe you can only say a few words, or it takes a long time to get a sentence out, or maybe you just can't even talk at all. And that's a good way to measure intensity. You also have time as another component of the FIT principles. So we say somewhere between 20 and 60 minutes for the average person, for the average, not athlete, but just for general health reasons when it comes to exercise and cardiorespiratory endurance. If you're at a high intensity, on the lower end of that scale is fine. If you're at a light intensity, we definitely recommend going up to that 60 minutes. And then the final T in FIT principle stands for type. And so this is anything that is rhythmic in nature, so repetitive. It does the same thing over and over again. Use a large amount of muscles in your body, and you do it for an extended period of time without stopping. So running, biking, those things, think about all those that you're doing. Something like throwing darts. Well, throwing darts is rhythmic. You can throw darts for a really long time, but it doesn't use a large amount of muscles, so it wouldn't necessarily count here. Bowling. Bowling is rhythmic in nature. Bowling also uses a large amount of muscles if done right, and you don't just walk up to the alley and drop the bowling ball. But you don't bowl for an extended period of time. Usually throw the ball down the lane and maybe throw it a second time, and then you go sit down for a while before your turn comes back up. So when you're looking at that, the type does have to match kind of that definition. And with that, we've now gone through assessment and all the way through how do we develop a program. And so in our next lecture, we'll talk a little bit more about some of the things that go along with cardiorespiratory endurance.